Alright guys, 11.3 composite figures. So composite figures are when you take two figures and you either jam them together to make one big figure that's made up of multiple things, or you rip them apart and you have one figure that's like a big thing minus a small thing. So some examples are like a paper towel roll or like a toilet paper. So if you look at this here, this is a composite figure. It's a big cylinder, and then you subtract out the little cylinder, right? Another classic example is if you think of like a house, right? You have a prism with a pyramid on top. Or maybe like a sharpened pencil, right? So if you think about a sharpened pencil, it's like a cylinder with a cone on top of it. So helpful hints. Hint number one, surface area is always just the surfaces you can touch. So when you look at this, if I were to find the surface area of this paper towel roll, it would be this outside lateral area plus the inside lateral area, because I can get in there and I can touch the inside of this, right? And then plus the two bases. So if you look at the bases are made up of a circle and another circle, right? You're gonna take the big circle and subtract out the little circle. So there's actually four parts to this. It's lateral surface area of this, the lateral surface area of this, and then the two circles on top of each other, the two donuts on top of each other, right? Helpful hint number two is when you find the surface area, it's helpful to find the lateral faces first, and then just add the two bases that you can touch, right? So I would find the lateral surface area of these two faces, these lateral faces here, and then I would add to it the two that I can touch, or three or five, or sometimes none. Sometimes you can't get to any, right? So we'll do a couple examples of each. So let's do a couple examples here. Example one, so you have kind of this crudely drawn, yours is nice, but mine's kind of crudely drawn L shape, right? So when I do this, I like drawing the base. So I'm gonna go ahead and draw the base for you here, right? And we're gonna try to find the lateral area, which is gonna be the perimeter of this shape, this base, times the height. So I'm gonna find the perimeter, and I'm gonna multiply the perimeter by 12, because that will take the face, and if you think about it, this base stays consistently all the way through the shape, right? So this is kind of like a prism type problem. So we need to find the perimeter of this thing, right? Multiply it by 12, and then we're going to, that'll be the lateral area, and then we're gonna add the two L's to it, so the two bases. So that's kind of my plan of attack there. Find the perimeter of this shape, multiply by 12, that'll be the lateral area, and then add the two bases to it, and that'll be the total area here. So let's go ahead. This is gonna be 16 on the bottom. This is gonna be, it's 5 in the back, so it's gotta be 5 up top too. This is gonna be 9. This is 4. Think about it, this is 9, this is 5, so doesn't this have to be 9 minus 5? So this will be 4 as well. And this is 16. This little part right here is 4, so if I drop that down, I'm gonna have 12 left. So if I add those numbers together, let's see here, 5 plus 16 plus 9 plus 4 plus 4 plus 12, the perimeter is going to be equal to 50, right? So if I want to find the lateral surface area, what I do is I take that perimeter and I multiply it by the height of the shape. So if I take that 50 times 12, the lateral surface area is going to be 600 units squared, right? So the lateral surface area is going to be 600, looks like we're in meters squared. Okay, now to find the total, what we need to do is we need to find the area of the base, and then you need to think about how many bases you have. So the bases are going to run parallel to each other, so each L is going to be a base, right? So you can do this a couple different ways. I'm going to cut it, you got to cut it somehow. I'll cut it like this, right? So the base is just going to be two rectangles kind of put together. So if you look at this rectangle is going to be a 5 by 12 rectangle, so the area of this guy is going to be 5 times 12, or 60. And this one's going to be 4 times 9, so this one's going to be 36. So that means each base is 96, right? 30 plus, so the area of the base is going to be 96 meters squared. And how many of those bases do I have? I have 2 of those bases. So if I want to find the total, it's going to be the lateral, which I found by taking the perimeter times the height, plus the one base, 96. Can I touch the front base? Yes. Can I touch the back base? Absolutely, plus 96. So 600 plus 96 plus 96 is going to give me 792 meters squared. There you go. Cool. Let's try example 2 here. So example 2, again, is another prism type problem, right? Because you have a base, and here the base is going to be made up of this rectangle, right? And this little semicircle here, right? So it's a cylinder on top of a prism, so it's going to be the same base all the way through. So what I need to do to find the area of the base, or to find the lateral area, is I'm going to take the perimeter of the base, and I'm going to multiply that by the depth of the shape, which is going to be 6, right? 6 minutes, doing good. Nice, let's try and keep it under 12 for you guys. So let's go ahead and do this real quick. So dimensions of the base. Well, this is 6 right here. That's 12 high, so this has to be 12 high as well. That'll be 12. That'll be 12. That'll be 12. So I know that this thing right here has a radius of 6, 6, 6, right? So if the whole thing's 15 and this part's 6, that means that this part has to be 9, right? Because 15 minus this radius 6 is 9, right? So what I need to do is I need to find the perimeter of this shape. So the perimeter of this shape is going to be 9 plus 9 plus 12, so 18 plus 12 is 30. But then I need to add to it this part of the semicircle, right? So circumference of a circle is equal to 2 pi r, but then we have to divide that by 2 because we only want half of the circle, right? So it's going to be pi times r. So the perimeter, the half the circumference of the circle, is going to be 6 pi, because the whole circumference is going to be 12 pi. So that means that the perimeter of the base is equal to 30 plus 6 pi, right? Now what I have to do is take that perimeter, that's the perimeter of the shape, and I need to multiply it by going this way, 6 deep, because I'm 6 deep here. So that's 12. We're going to multiply it by 6 deep. So take that thing and multiply by 6. So that'll be 240. Lateral area is 240 plus 36 pi. Right? So that's just my lateral area, and my units are inches squared. Okay. Now what I have to do is I have to add to it the bases. So I have to take that plus the bases. And how many of those bases do I have? Well, I have a front base and I have a back base, so multiply it by 2. Right? So let's find the area of the base real quick. The area of this base, this part right here, I'll do this in blue, is going to be 9 times 12. So 9 times 12 is going to be 108. And then the area of this thing is going to be pi r squared divided by 2, because it's going to be half my circle. So pi times 6 squared divided by 2. 36 pi divided by 2. 18 pi. Right? So the base is going to be 108 plus 18 pi. And then I have to take that, and I can touch the front base and I can touch the back base. So I'm going to take that, I'm going to multiply by 2. So that's going to give me 216 plus 36 pi. Right? So that's going to go, that's my 2 bases. Now if I want to find the total, I just take my 240 plus 216, so that gives me 456. Right? Lateral plus this plus 36 plus 36 is 72 pi. And something that you might have done on that quiz is try to combine those, but we can't do that because remember these are unlike terms. And then that's going to be inches squared is the units. Cool. Right? Let's keep going here. So this one's a little different. I tried to pick 4 good examples that would hopefully illustrate all the different problems that you can see. I know it's tough. The problem with this is you can't do all the problems because you can always build shapes out of other shapes, right? So the base here, this is going to be a paper towel roll. So again, you got your toilet paper, right? So you got your hole here where you can touch the inside of this. So you're going to take this cylinder plus this cylinder. That'll be the lateral surface area. And then you're going to add to it the 2 circles, or the donut, if you will. So the base is going to look like this. Base is going to look like that. The radius of the little circle is going to be 3, and the radius of the big circle is going to be 5, right? So let's do the lateral area first. The lateral area is going to be the little cylinder plus the big cylinder. So remember, to find the cylinder, it's going to be 2 pi r times the height of the cylinder, which is, for us, is going to be 12. So I have to take 2 pi r the little guy, 2 pi r the big guy, and then go ahead and multiply both by 12. So 2 pi times the little guy is going to be 3 times 12, and 2 pi times the big one, which is 5 times 12. So the lateral surface area here is going to be 6 pi times 12, and that's going to be 10 pi times 12. So it's going to be 72 pi. That's going to be the little guy, little cylinder, and this is going to be 120 pi. That's going to be the big cylinder. So when I add those together, I get 20. Make sure I don't make any mistakes here. 192 pi. So that's my lateral surface area. Now, how many bases do I have? Well, I have the top base and I have the bottom base. So I got to take this base and multiply by 2. Right? And if you think about it, to find the area of the base, what you're going to do is you're going to take the big circle and you're going to subtract out the little circle, and that'll give you kind of that donut. So the big circle is going to be 25 pi. The little circle, pi r squared, is going to be 9 pi. And when I subtract the 2, I'm going to get 25 minus 9. Let's see here. That's going to be 16 pi. Right? So each circle is going to be about 16 pi. And then I need to take that and multiply by 2 because there's 2 bases. Right? So 16 times 2 is 32 pi. So that's going to be the area of my bases. So 192 plus 32 gives me 244 pi, and then our units here is centimeters squared. Cool. So again, we've had 3 prism type problems so far because we've had 2 of the bases, right? Last one here. So this one we actually have more of a cone type problem here, right? And remember, to find the lateral area of the cone, it's going to be pi r L, where L is this lateral edge right here, slant height. Okay, so when you think about it, what we have is we have a cone and another cone, and they're the same, right? And then you have a cylinder in the middle. So this actually doesn't have any bases to it. There's no bases. Some people think I can go in here and reach in there and touch it. No, if this thing's made out of wood or brick or something, you can't get your fingers in there to touch this base or touch this base. So here there's going to be no bases to add, which is kind of nice. So what we need to do is we need to find the lateral area of this cone plus the lateral area of this cone, which will be the same, plus the lateral area of this cylinder. So I'll try to do this for you in an easy way. So that's 6. This has to be 3.5, right? So I can do Pythagorean theorem to get what this is. Let's see here, the 7, 12. I bet this is 13. I bet this is... I bet it's 6.5. It is. So when we do Pythagorean theorem, a squared plus b squared equals c squared, this will be 6.5, right? And then that means this will be 6.5 as well. Remember, we don't care about the altitude. We care about this lateral edge or slant height over here for the cone. Okay, and then this one, kind of the same thing. So if I know that's 3.5, I know this is 3.5 as well. So I know this is 7. And then I can do a squared plus b squared equals c squared, and I can get this to be 24. Cool, so now I have everything I need. So let's find the surface area of this one. So it's going to be pi times r, which is 3.5, times L, which is 6.5. And that's actually going to be the same thing as this one, pi times R times 6.5. And this one, so that'll go here, that'll go there, that'll go there. This one will be 2 pi R times H, right? So 2 pi R is going to be 7 pi, because my radius is 3.5, times H, which is 24. So let's go ahead and let's find out now what these things are using our calculator. So we'll do 7 times 24. That's going to be 168 pi. 3.5 times 6.5, that's going to be 22.75 pi. Same thing here, 22.75 pi. And then when I go ahead and I add them together, I get 22.75 times 2 plus 168. That gives me 213.5